So an example of impulse. Let's say it's a hot summer day and you're outside and there's a swimming pool and you close your eyes and you jump into the swimming pool, making a cannonball. And right before you reach the bottom of the pool, you forgot to check that there's water in the pool before you jump. So right over here, you're moving downwards, say, with 1 meters per second. So if you're moving downwards with 1 meters per second right before you hit the bottom of the pool, a short time later, you're going to be on the bottom of the pool with a velocity equals to 0. And let's say you weigh about 80 kilograms, so your mass is 80 kilograms. So, well, you might not be dead, but you will definitely look next time before you jump. So we can calculate your change in momentum. So your initial momentum is just your mass times your initial velocity. So it's 80 kilograms times your velocity, which we take as 1 meters per second downwards. So I'm just going to write down. So it is 80 kilograms meters per second down. Remember, momentum is always a vector. So that's your initial momentum. Your final momentum is 0. So your change in momentum is just what you ended up with minus what you started out with. So this will be 0 minus 80 kgs meters per second downwards. So it's minus 80 kilograms meters per second downwards. The minus changes our direction. So your total change in momentum is actually 80 kilograms meters per second upwards. Okay, that might seem a bit strange, but if all your momentum is downwards, the only way you can decrease it is to add momentum in the opposite direction. So that's why your change in momentum is going to be upwards. And let's say the time it took the collision, so the time it took you to move basically from there to there coming to a halt, let's say it is 0.1 seconds. So it takes a very short time for you to basically come to a complete stop. So the average force that you will feel then is your change in momentum divided by the time taken. So this is 80 meters per second upwards divided by 0.1. So it ends up being 800 newtons upwards. Now that is the equivalent of an 80 kilogram person sitting on you. So that's about the force that you'll be feeling on average during that moment. So it probably hurt a bit. Let's now look at the case where there is actually water in the pool. Right, so here's the pool, and there's the water, and there you are going again. And let's say again here your velocity is 1 meters per second downwards. Because there's water in the pool, at some later time, you are very happily right at the bottom of this pool, and you hopefully took a big breath before you jumped in, and obviously your velocity here is 0. And let's say, if I need to go from experience, if you jump into a pool, the time it takes you to reach the bottom, I would say it's roughly a second, perhaps a bit more. So the time it takes for you to experience going from 1 meters per second to 0 meters per second is, let's say, 1 second. So your change in momentum, we end up with 0. We started up with 80 kilograms meters per second downwards. So we get the same change in momentum because we start with the same velocity, we end with the same velocity. So it's 80 kilograms meters per second upwards. But now the average force that you feel is 80 kilograms meters per second upwards divided by 1 second. This is 80 newtons upwards. So on average you feel a force of 80 newtons upwards, which is basically the equivalent of a big bag of sugar lying on you. So it's a much better proposition. So the reason that happens is because the water is now there, it extends this time over which you undergo the same change in momentum. And if that happens, the average force that you feel will be less. Right, so that is pretty much momentum and impulse in a nutshell.